Hello students, once again welcome you to GK's maths classes. Today in continuation of applications of differentiation, we will be doing problems under increasing and decreasing function. In part 1 of the video, I have introduced you to the concept of increasing and decreasing function, and we have solved a few questions from NCERT and as well as from board papers. Today we are going to continue with more problems in increasing and decreasing function. However, what I will do, I will put the part 1 of the video in the description box for your reference in case you wanted to go through the details of the introduction of increasing and decreasing function. So let us go to this main thing. Like what I am going to do is straight away we are going to solve problems. Before that, just a quick understanding of what an increasing function is. Okay. Now if I have a function y equal to f of x, okay, if y equal to f of x, then if you say the function is increasing if the derivative is greater than 0, if dy by dx is less than 0, you say the function is decreasing. So when I say it is strictly increasing, okay, it is strictly decreasing. Suppose if it is greater than or equal to 0, you can say increasing. Less than or equal to 0 will be decreasing. Okay. And then of course there are a lot of details that goes into it. An increasing function looks like this, whereas a decreasing function will be like this. Okay. When I say dy by dx, I am talking about the slope. For an increasing function, the slope makes acute angle with the positive direction of x-axis, whereas for a decreasing function, a tangent makes obtuse angle with the positive direction of x-axis. These are the details I have explained in detail in part 1. Please refer to that in case you need more details. Now we'll do the problems. Find the interval in which the function is increasing and decreasing. Here the function is x by x square plus 1. Okay. Now what I will do, first I will take the function x by x square plus 1 and I will differentiate dy by dx. How do I differentiate this? I am going to use quotient rule. X square plus 1 the whole square, x square plus 1 the whole square, and I will get x square plus 1. Differentiation of x is 1 minus x into differentiation of x square will be 2x and differentiation of 1 is 0. So I am using quotient rule. Very simple. So now you have dy by dx is equal to, if I simplify this, I get 1 minus x square, because this is x square, this is minus 2x square, it becomes minus x square, divided by x square plus 1 the whole square. Okay. Now if you want, you can write this as 1 plus x into 1 minus x divided by x square plus 1 the whole square. So this is my dy by dx. This is my first step. Now what is the second step? The second step is I have to put dy by dx as 0. This is where I check where this is a critical point where the curve changes from increasing to decreasing or from decreasing to increasing. Okay. So it's very important that you find dy by dx equal to 0. So when I equate it to 0, what will I get? 1 plus x into 1 minus x divided by x square plus 1 the whole square. I equate it to 0. So I will get x is equal to 1 and x is equal to minus 1. What's the third step? Third step is I have to split the intervals. So what are the intervals? The intervals are, look at this, this is minus 1, this is plus 1. So the intervals will be minus infinity to minus 1, minus 1 to 1, and then 1 to infinity. Minus infinity to minus 1, minus 1 to 1, 1 to infinity. Now I have to check in these intervals whether the dy by dx is positive or negative, to check whether it is increasing or decreasing. So that is my fourth step. Now what is my fourth step? I choose the interval minus infinity comma minus 1. Now choose a number in between minus infinity and minus 1. It can be any number. Minus 2. So dy by dx will be what? dy by dx will be If I put it here, I will get, if I can put here or here, doesn't matter where I want to put. So I'll put it here. So you get minus 4. 1 minus 4 is minus, so it's negative on the numerator. And denominator is always positive because it is whole square. So what is negative by positive? It's always negative. Therefore, the function is strictly decreasing. Where it is decreasing? In minus infinity, comma, minus 1. Now what I will do, I'll choose the next interval. What is the next interval? The next interval is minus 1, comma, 1. Now choose a number between minus 1 and 1. So the number that I am going to choose is 0. And I will substitute in dy by dx. Let me write here where I am substituting so that it is clear to you. It will be, I will substitute in 1 minus x square by 1 plus x square the whole square. So when I substitute 0, I get 1 minus 0. 1 minus 0 is positive. And denominator is always positive. So this is greater than 0. So since dy by dx is greater than 0, what do you say? The function is strictly increasing, where in the interval minus 1, comma 1. Simple, isn't it? Now what do you do? Choose a number between, choose the next interval and a number in between that. I'll choose 2. Now dy by dx will be, when I choose 2, it is 1 minus 4, that is negative, divided by positive, which is again negative. Therefore, the function is strictly decreasing. Where it is decreasing? In 1, comma, infinity. Now I have to write the conclusion. So what is the conclusion? I will say the function is strictly decreasing. Where it is strictly decreasing? In minus infinity, comma, minus 1, union 1, comma, infinity. And the function is strictly increasing, where in minus 1, comma 1. Okay, the same procedure, only the functions are different, the method, everything is the same. Now let's look at it visually using GeoGebra. I'll go to GeoGebra, yeah, it's here. Now I'll write the function y equal to x divided by x square plus 1. X divided by x square plus 1. So that's the function. So I'm closing it. Now you can see clearly here dy by dx is negative. If you want, I can just show you taking a point. Choose a point on it and I'll draw the tangent. This is a tangent and I'll find the slope of the tangent. So this is the slope of the tangent. You can see clearly the slope of the tangent is positive. So sorry, is negative. So from minus infinity till where it is negative. See, my slope is always negative. Look at the value of slope. Slope is negative. I am moving A. Okay. So when it reaches this particular point, it reaches the point minus 1. When x is minus 1, my dy by dx is 0. That is what we got. Now from minus 1 to 1, see, it is dy by dx is positive. So it is increasing. Can you see the curve is increasing? When x increases, y increases. And it reaches a point, the point 1. At 1, dy by dx is 0. Correct? Again, from 1 to infinity, it starts decreasing. See, dy by dx is negative. Okay? So it's very easy. Visualization is very, very important. I hope this is useful to you. Okay? Okay, let's go to the next one. We'll go to the next problem. The question here is, find the interval in which the function is increasing or decreasing, and the function is x minus 1 the whole cube into x minus 2 the whole square. Now how do I do that? So first let me write the function y equal to x minus 1 the whole cube into x minus 2 the whole square. Okay. So I'm going to find dy by dx. That is our first step. So I want to find dy by dx. Dy by dx. So what is dy by dx? I'm going to use product rule. X minus 1 the whole cube. Now differentiation of x minus 2 whole square will be 2 times x minus 2. I'm using chain rule, and differentiation of x is 1 plus x minus 2 the whole square, and differentiation of x minus 1 whole cube will be 3 times x minus 1 the whole square. Now I need to simplify this. Now how do I simplify? I'll check what is common. X minus 1 whole square is common, and I also have x minus 2 as common. So what you're left with, I'll get 2 times x minus 1 plus 3 times x minus 2. Correct? So I took out common, I got this. So this is nothing but x minus 1 the whole square into x minus 2. And if you simplify this, I get 5x, correct, minus 8. How did I get 5x minus 8? 2x plus 3x is 5x, minus 2 minus 6 is minus 8. So this is my dy by dx completely simplified. So I have differentiated and I have simplified. This is our first step. What is my second step? My second step is I want to find dy by dx equal to 0 and find the critical points. So what are they? I'll get x is equal to 1, x is equal to 2, and x is equal to 8 by 5. I got all the critical points. Now what are the intervals? The intervals are, this is 1, okay. 8 by 5 is 1.6, okay. So it is somewhere here. This is 8 by 5 and this is 2. Now how do I break the interval? I break the interval as minus infinity comma 1, 1 comma 8 by 5, and then 8 by 5 comma 2, and finally 2 comma infinity. There are totally 4 intervals. Okay. Now let's go one by one. So let me take dy by dx. So my dy by dx will be x minus 1 the whole square, x minus 2 into 5x minus 8. This is where I'm going to substitute. Now choose the interval minus infinity comma 1 and a number inside that. I'm choosing 0. So what is dy by dx? Dy by dx is, when I put 0, you get positive. Correct? And a minus 1 whole square is always positive. Now 0 minus 2 is negative. And 0 minus 8 is also negative. So positive into negative is always positive. Therefore, the function is strictly increasing, where in minus infinity comma 1. Okay. Now choose a number between 1 and 8 by 5. Remember, 8 by 5 is like 1.6. 8 by 5 is 1.6. So I will choose 1.5. So I choose 1.5. So when I choose 1.5, what happens to my dy by dx? I don't even have to think here because this is going to be always positive because it's x minus 1 whole square. So this is positive. What is 1.5 minus 2? 1.5 minus 2 is going to be negative. And what is 1.5 minus 8? 5 into 1.5, which is 7.5. 7.5 minus 8 is always negative, right? So what is negative into negative? Negative into negative is always positive. Therefore, what do you say? The function is strictly increasing in 1 comma 8 by 5. Actually, this is very obvious because x minus 1 whole square, the turning point happens at 1. So since it is whole square, definitely it is going to continuously increase only to the left side of 1 and to the right side of 1 also. If you want to change, we'll come to the, we'll write the conclusion later. Okay, first we'll come back to the problem. Now I want to choose 8 by 5 comma 2. So I can choose say 1.7. Okay, 1.6, and then so it's 1.7. So what is dy by dx? Dy by dx is going to be positive. This is positive. And 1.7 minus 2 will be negative. And What is 1.7 into 5? 7 5 is 35. So it is 8.5. 8.5 minus 8 will be positive. Okay. So this is always positive. Therefore, the function is strictly increasing. Sorry, it is negative. Sorry. Positive, negative, negative is negative, strictly decreasing in 8 by 5, comma 2. Now finally, I choose the interval 2 comma infinity and I substitute say 3. What about dy by dx? This is going to be positive. First, it's always positive. 3 minus 2 will also be positive. And 15 minus 8. 15 minus 8 also will be positive. Therefore, I can say the function is strictly increasing in 2 comma infinity. So how do I conclude? I can say the function is strictly increasing where in minus infinity comma 1, union 1 comma 8 by 5, union 2 comma 8. And the function is strictly decreasing where in 8 by 5 comma 2. There's another conclusion which I wanted to highlight to you. We can say the function is increasing. I remove the word strictly. The function is increasing where in minus infinity comma 8 by 5. Because in minus infinity comma 8 by 5, 1 is there. At 1, dy by dx will be 0. At 1, dy by dx will be 0. So it won't be strictly increasing, but it will be increasing. Suppose they ask you strictly increasing, you have to remove 1. If it is increasing, you can include 1. Is that clear? Let's go back to let us have a visualization of this graph. So what is the function? Y equal to x minus 1, x minus 1, x minus 1 whole cube into x minus 2 the whole square, x minus 2 the whole square. So this is the graph. So very beautiful graph. You see there's a slight bend here. Okay, we'll see what it is. Choose a point on it. Okay, I'm sorry, this is a mistake. Choose a point on the graph and I will draw a tangent to the graph and I will find the slope. What do you say about the slope? Slope is positive, correct? Now I'm going to change. So I'm moving it. So slope is positive. Can you see still the slope is positive? When I reach 1, my slope is 0. dy by dx is 0. Okay. Look at that. At 1, dy by dx is 0. Now I'm going to move away from 1. Still you can see the slope will be positive. Still it is positive. So you can see to the left side of 1 as well as to the right side of 1, the function is increasing. Left side of 1 and right side of 1, it is increasing. That is why we got minus infinity to 1, it is increasing. 1 to some other point was also increasing. What is that some other point? Now I come to a particular point. See, it is still positive. Now it's going to become 0. I think I have to zoom in and check. Oh, it came there. There it is. 1.59 is approximately 1.6. Because of scale, there will be error. 1.6 at dy by dx is 0 at 1.6. See, at that point dy by dx is 0. Now you can see to the left of it, it's positive and it becomes 0 and becomes negative. See. So from where to where it is 0? from 1.6 to 2, it is negative. Can you see it? It is negative. 1.6 to 2, it is negative. Therefore, function is decreasing. And then at 2, dy by dx is 0. And then again it starts increasing. So the idea is from minus infinity to 1 it is increasing. And then from 1 to 1.6 also it was increasing. And then it's decreasing followed by increasing. If you want to visualize it in a little better way, you can zoom in and see. So you can just zoom in and see so that you can see that. See, it goes up and reaches this, again it starts increasing, then it decreases, then it increases. Okay. I hope you understand that. Okay. Let's go back to our problem. Now let's go to the next question. Find the interval in which the function is increasing or decreasing, where f of x is equal to x cube plus 1 by x cube. It's one of the important questions. So what I will do, first I will take the function y equal to x cube plus 1 by x cube. Then I differentiate. What is dy by dx? Dy by dx will be 3x square minus 3 by x power 4. I hope you know how to differentiate x power minus 3. X power minus 3 is minus 3 by x power 4. Now I need to simplify this slightly. So dy by dx will be 3 times x power 6 minus 3 by x power 4. So this will be 3 times, can I say this is x cube plus 1 into x cube minus 1? Okay. I took 3 outside, x cube plus 1 and x cube minus 1. Now I put dy by dx is 0. When I put dy by dx is 0, I will get x cube plus 1 is 0 and x cube minus 1 is 0. So I get x cube equal to minus 1. So x is minus 1. Others are complex roots, so I'm not interested. So x cube is 1, therefore x is 1. So you have got 2 turning points. One is minus 1, other one is 1. So this is minus 1 and this is 1. Now I want to split the intervals. So what are the intervals? The intervals are minus infinity comma minus 1, then minus 1 comma 1, and then 1 comma infinity. But if you observe carefully, this function does not exist at 0. So it is very important that you remove it. Okay? So minus 1 comma 1, 0 cannot be there because at 0 the function does not exist. Okay. Now choose, take dy by dx. What is my dy by dx? My dy by dx will be 3 times, you can say x cube plus 1 into x cube minus 1 divided by x power 4. Choose the interval minus infinity comma minus 1 and substitute minus 2. What is dy by dx? Dy by dx will be 3 times, this will be negative, minus 2 whole cube is minus 8, minus 8 plus 1 is 7. And this also will be negative, right? Divided by positive. So negative into negative is positive, positive by positive is positive, therefore the function is strictly increasing, where in minus infinity comma minus 1. Now choose a number between minus 1 comma 1 excluding 0. So definitely you can't choose 0. So here I will choose half, or I will choose 0.5. Okay. So dy by dx will be what? Dy by dx will be 3 times 0.5 whole cube plus 1 will always be positive. 0.5 is a 0.5 whole cube will be a small number, minus 1 will be a negative number divided by positive. So positive into negative is negative. Negative by positive will always be negative. Therefore the function is strictly decreasing in minus 1 comma 1 excluding 0. Now choose a number between 1 and infinity. I will choose 2. So dy by dx will be 3 times. When I choose 2, it becomes positive, and this is 8 minus 1 is also positive divided by positive. Therefore, I can say the function is strictly increasing in 1 comma infinity. Now, how do I write the conclusion? The conclusion is the function is strictly increasing in minus infinity comma minus 1 union 1 comma infinity, and strictly decreasing where? In minus 1 comma 1 excluding 0. So the method is the same. There's no change at all. Only thing is the function is different, and you have to be very careful with your calculations. So let's have a look at it using GeoGebra. So what is the function? The function is y equal to x cube plus 1 by x cube. 1 divided by x cube. X cube divided by 1 by x cube. Correct? So you can see this is the graph. Okay. Now choose a point on the graph, on the curve. I choose a point. Let me draw a tangent. Correct? Now find the slope. This is the slope. So what happens to slope? Slope is positive. Now I move it. So when it reaches minus 1, slope is 0. So minus infinity to minus 1. Minus infinity to minus 1. The function is increasing. And then from minus 1 to 0, minus 1 to 0, it is decreasing. Minus 1 to 0, it is decreasing. Correct? And then it continues here. You see, it is still decreasing only. It is still decreasing. From minus 1 to 1, it is still decreasing. You can see for yourself. It was here, right? It was decreasing. It was decreasing. Can you see it? Now I am moving from minus 1 to 1. It is still decreasing. Now when you reach 1, it is 0. When I reach 1, it is 0. And then from 1 to infinity, it is still increasing. And you can see clearly this graph is not defined at 0. That is why there is no graph at 0. These curves are asymptotic to y-axis. Asymptotic to y-axis. They will never intersect the y-axis. Okay? They will never intersect the y-axis because at x is equal to 0, y is undefined. Okay? I hope it's clear to you. Visualization is the best way that you can understand things. Okay, let's go to the next problem. This is again a very simple, straightforward problem. It's not at all complicated. So let's try it. So what is y equal to 4x square? Can I write it as 4x square by x plus 1 by x, because this makes it a little easier for me. Or otherwise you can straight away use quotient rule. I don't have a problem. So it gets cancelled. So what is dy by dx? This again you can simplify it as 4x plus 1 by x. So I am differentiating this. Dy by dx, what is that? Differentiation of 4x is 4. 1 by x is minus 1 by x square. 1 by x is minus 1 by x square. Now put dy by dx as 0. When you put dy by dx as 0, you get 4 equal to 1 by x square. Therefore, x square equal to 1 by 4. Therefore, x is equal to plus or minus 1 by 2. So you get x is equal to plus or minus 1 by 2. Now, this is minus half and this is plus half. Now, I am going to split the intervals. The intervals are minus infinity comma minus half, minus half comma half, and then half comma infinity. And very clearly you should know that x cannot be 0. So I have to remove 0, just like the previous problem, correct? Now what do you do? Choose a number between minus infinity and minus half. A number between minus infinity and minus half I'll choose is minus 1. And what happens to your dy by dx? Dy by dx will be 4 minus 1. Okay, minus 1 whole square will be 1. So this is positive. Therefore, the function is strictly increasing where? In minus infinity comma minus half. Very simple. Now choose a number between minus half and plus half, and of course you cannot choose 0 because 0 is removed. Choose a number between minus half and plus half. So I will choose, say, 1 by 4. So what happens to your dy by dx? Dy by dx will be 4 minus 1 by x is 1 by 4. So it will be 1 by 16. So it will be 4 minus 16, which will be negative. Therefore, the function is strictly decreasing where? In minus half comma half, excluding 0. Very important that you exclude 0. Okay. Now half comma infinity. Choose a number between half and infinity. I'll choose 1. So what is my dy by dx? Dy by dx will be 4 minus 1 because 1 square is 1. So it is positive. Therefore, you say the function is strictly increasing in half comma infinity. So what will be my conclusion? My conclusion will be the function is strictly increasing. Where it is strictly increasing? Minus infinity comma minus half union half comma infinity. And the function is strictly decreasing. Where it is strictly decreasing? Minus half comma half. You have to remove 0. Why do I remove 0? Because the function is not defined at 0. Okay. So let's have a look at it, how it looks graphically. Just a second. So my function is y equal to 4x square plus 1, 4x square plus 1, right? 4x square plus 1 divided by x. So this is the graph. And let me close this for you to visualize. See, again, it is exactly like the previous. In fact, both the curves are almost the same because, and you see, the function is not defined at 0 and there is no graph at 0. Okay. Now, let me choose the point to show you the tangent. So I'll choose a point here. I will draw the tangent and I will find the slope. You see, slope is positive. See, your x value is minus 1.2. Okay. So when I reach half, my dy by dx will be 0. When I reach half, minus 0.5, dy by dx is 0. So minus infinity to half, it is increasing. Can you see? From minus infinity to half, it is increasing. Then what happens? From half, I'm moving from half, and I am moving. Okay, and I have reached here. See, from minus half till I reach half. Till I reach half, it will be decreasing only. You can see again, slope is negative. You see, slope is negative. There it is gone. Okay, slope is negative. Okay. I'm not able to see it. I think it has gone to that x-axis. Okay. Okay. Where it is? Let me make it move. Okay, I got. See here, it is 0. See, from minus half to half, it was still negative. Then it becomes 0 at half. Then again, it starts increasing. So, from minus infinity to half, minus infinity to minus half to half, it is increasing. It is decreasing. Sorry, minus infinity to half, it is increasing. Minus half to plus half, it is decreasing. And then from half to infinity, it is increasing. And the graph is not defined at 0. That is why there is no graph at x is equal to 0. Okay. Let's go back to this. Find the interval in which the function is increasing or decreasing. This is the function. So y equal to log of x plus 1. Very important question. It has come in the board exam and it is there in the NCERT book also. So I want to differentiate this. What is dy by dx? So dy by dx will be 1 by x plus 1 minus, what is differentiation of 2x by x plus 2? It is 2 plus x the whole square and 2 plus x, quotient rule, into 2 minus 2x into differentiation of 2 plus x is 1. So if I simplify this, what will I get? 1 by x plus 1 minus 4 by 2 plus x the whole square. 2x gets cancelled. I'm just taking LCM. What is the LCM? X plus 1 into x plus 2 the whole square. So what do I get on the numerator? X plus 2 the whole square minus 4 into x plus 1. Just taking LCM, normal LCM. So this will be x square plus 4x plus 4 minus 4x minus 4. I used a plus b whole square and I open the bracket. I get x plus 1 into x plus 2 the whole square. They get cancelled. So what are you left with? I am left with x square by x plus 2 the whole square into x plus 1. So this is my dy by dx. What is my dy by dx? So my dy by dx is x square divided by x plus 2 the whole square into x plus 1. Done. Now very important, listen to the argument very carefully. You all know x square is always positive. X square is always positive. X plus 2 whole square is also positive. Correct? So dy by dx is going to be negative or positive, will be determined only by x plus 1. Yes? Because x square and x plus 2 whole square is always positive. So the nature of dy by dx will be determined only by x plus 1. So can I say my differentiation, my derivative will be positive only if x plus 1 is positive? That means x must be greater than minus 1. What do you mean by greater than minus 1? Greater than minus 1 means the function is strictly increasing in minus 1 comma infinity. Strictly increasing from minus 1 comma infinity. Then you can say dy by dx is less than 0 when only if x plus 1 is less than 0. When I say x plus 1 is less than 0, x is less than minus 1. Therefore, can I say the function is strictly decreasing where? In minus infinity comma minus 1. This is what generally everyone does. But one important thing that we all forgot, that this logarithm is defined only for positive values. So that means your 1 plus x must always be positive, yes or no? You cannot have 1 plus x as negative because log is not defined for negative numbers. So the domain of logarithm is from 0 to infinity, 0 not included. So definitely log of 1 plus x is possible only when x plus 1 is positive. Or you can say, or when x is greater than minus 1. So this situation is completely ruled out. You cannot have this. Don't write this in the exam. Just to make you understand and just to tell you what mistakes students do, I have highlighted it. Otherwise, you should not be writing this in the exam, because this function is defined only when x is greater than -1. We don't even have to talk about x less than -1. So here, this function is always increasing. It will never be decreasing. Okay, let us have a look at it. Okay. Now, what is the function? Here, my function is 2 times y equal to 2 times log 2 times ln okay, I'll change this. 2 times ln of, it should be natural logarithm, so I'm putting ln of 1 plus x, or 1 plus x minus, it should be 2x divided by x plus 2. 2x divided by x plus 2. Then this is the graph. You can just have a look at the graph. What a lovely graph. The graph will not go beyond -1. In fact, it will not intersect the line. This graph will never touch the line x is equal to -1. It will never touch. It is only asymptotic. If you can zoom in and see. Now, let us see. Let us choose a point. Let me draw a tangent. Okay, and let me find the slope. You see, slope is always positive. From where? From -infinity, you keep going wherever you want. It is always positive. So this function, logarithmic function, is an increasing function. From where? From -infinity to +infinity. From -1 to +infinity, it is always increasing. So this particular function is always increasing. You can visualize it. It's very, very clear. Is it clear? Okay. Let's go to the next one. Now the next question is, you have 2 times log of x minus 2 minus x square plus 4x plus 1. So obviously you should know by now that x minus 1 should be positive, or x should be greater than 2. Okay. Now let's find dy by dx. What is dy by dx? Dy by dx will be 2 times differentiation of log x minus 2 will be 1 by x minus 2 minus 2x plus 4. Okay. Now take LCM. What is LCM? LCM is x minus 2, and the numerator will be 2 times minus 2x into x minus 2 plus 4 into x minus 2. I'm just taking LCM, nothing else. Here it is by 1, so it is by 1, so it is LCM. So this is 2 times minus 2x square plus 4x plus 4x minus 8 divided by x minus 2. I just open the bracket. Okay, so this will be minus 2x square plus 4 plus 8x, 2x square plus 8x minus 6 divided by x minus 2. Can I take minus 2 outside? So it will become x square minus 4x plus 3 divided by x minus 2. This is a quadratic equation which can be factorized as x minus 1 into x minus 3 divided by x minus 2. Correct? So this is my dy by dx. Now how do I find the critical point? Here it's very difficult to look at positive. In the previous problem, it was very clear that only this x plus 1 was positive. X plus 1 can be negative or positive. All other terms were positive. But here it is very difficult. So what I will do, I'll find the critical points. So I will equate it to 0. When I equate it to 0, what happens is, I will get x is equal to 1, and I will get x is equal to 3, and I should get x is equal to 2 also, because this is both positive as well as negative. If it had been x minus 2 whole square, I would have ignored it. But it is x minus 2. It can be positive as well as negative. So dy by dx is going to be negative or positive, will be contributed both by the numerator and denominator. Okay. So first let's do that. Then I will write 1, then 2, then 3. Okay. Now what are the intervals? The intervals are minus infinity comma 1, 1 comma 2, 2 comma 3, and then 3 comma infinity. Minus infinity to 1, 1 to 2, 2 to 3, 3 to infinity. But clearly you see x is greater than 2. So these two intervals should never be considered. These two intervals should never be considered. Okay. So what I will do, I will take 2 comma 3, and I will take say 2.5 and substitute in dy by dx. What do you get? Minus 2 into, this is 2.5. 2.5 minus 1 is positive. 2.5 minus 3 is negative, and 2.5 minus 2 will be positive. So negative into negative is positive. Therefore, the function is strictly increasing in 2 comma 3. Now choose a number between 3 and infinity. I'll choose 4. So what do I get? Dy by dx will be minus 2 times 4 minus 1 is positive, 4 minus 3 will be positive, and 4 minus 2 will be positive. So this is negative, because negative into negative is negative. Therefore, the function is strictly decreasing in 3 comma infinity. Actually, there is no need to do all of these. It's time waste. I just want to establish a common method. That's why I did this. Otherwise, if you analyze the problem very carefully, it is given that x is greater than 2. Okay. Since x is greater than 2, this is always positive. Okay. And this is also positive. Correct? Since it is x is greater than 2, both are always positive. So dy by dx is going to be negative or positive, will be decided only by x minus 3. So when x minus 3 is positive, dy by dx will be negative. Why? If this is positive, there is a negative sign there. So it will be decreasing. So that is why you got at 3 comma infinity it is decreasing. When x minus 3 is negative, that is when x is less than 3, negative into negative will be positive, you get increasing. So you can argue like that also. But if you don't want to think too much, this is the best way. But no way you will write these two intervals. These are wrong. Okay? Because x is definitely greater than 2. Let's visualize the graph. I have got y equal to 2 times ln of x minus 2, x minus 2, I suppose, ln of x minus 2, and then minus x square plus 4x, and then plus 1. Look at it. So this is the graph. And you see the graph do not exceed 2. It doesn't go below 2. That is why x is greater than 2. So no way. If you go down, if you zoom down and see, if you can use GeoGebra and check, your graph will not go below 2. It will always be, not even it will touch 2, because log of 0 is undefined. So it will not even come to 2. This x is equal to 2. That line x is equal to 2 will be asymptotic to the curve. Okay. So let's, as usual, try the tangent and check whether everything is okay. This is the point, and I will draw the tangent. Then I'll find the slope. Definitely the slope will be positive. Okay, so now I'm moving it. So when I move it, you see it's always positive. It's always positive. It's always positive. Till where? Till I reach this wonderful point 3. So from 2 to 3 it's increasing. From 2 to 3 it's increasing. From 3 onwards it starts decreasing. 3 to infinity it is decreasing. Very clearly demonstrated using the graph. This will give you a better understanding of what increasing and decreasing functions. Always visualize the graph. Okay, let's do the last problem for the day. With that we'll stop, and then we'll continue problems involving trigonometry in the next class. Okay. Now this is the last problem. Y equal to 5x power 3 by 2 minus 3x power 5 by 2. Now how do I do this? So first of all I want to differentiate this. So what is dy by dx? Dy by dx is 15 by 2 x power half minus 15 by 2 x power 3 by 2. Okay, we just used to nx power n minus 1, nothing great. Now here what is common? 15 by 2 is common, x power half is also common. So what do I get? I will get 1 minus x. Why? X power 3 by 2 is x, correct? It is x power 1 into x power half. So I took x power half out, so I will get x. Now it is very clearly given that x is greater than 0. It is very clearly given that x is greater than 0. So this is always positive, right? So dy by dx is going to be negative or positive. Since x is greater than 0, root x is always positive, correct? This is root x. So dy by dx is going to be negative or positive, will be decided only by what? Only by 1 minus x, correct? So what do I get? 1 is less than x or x is greater than 1. Therefore the function is strictly decreasing where? In 1 comma infinity. Now what happens to the next part? Dy by dx will be positive only if 1 minus x is positive. That is 1 is greater than x or x is less than 1. Therefore the function is strictly decreasing where? You can't write minus infinity comma 1. This is what many students will do. This is wrong. If you do that, you will cut marks. It will be from 0 to 1 because the graph is not defined beyond 0. Okay. So I hope this is clear to you. Just let's quickly visualize the graph and then we'll stop the class. New one. So what is the graph like? 5 into x power 3 by 2, x power 3 divided by 2, and then minus 3 x power 5 by 2, right? 5 by 2. So that's the graph. I got the graph. See this graph? And you can see clearly there is no graph beyond 0. To the below 0 you cannot find graph because x power 3 by 2 means x root x. Root is possible only when x is positive, right? That is why, that is the reason. I hope you know the reason. Okay, I'll put the reason. When you say x power 3 by 2, it is x root x. So root x is possible only when x is greater than 0. So even if they don't mention in the question, you are supposed to know it. Okay. Okay, let's complete this part. Choose a point. Choose a point. I think there's a problem there. I'm sorry. Choose a point. One second. is a point. I'll draw the tangent. I'll find the slope. You see slope is positive. From where? From 0 onwards. From 0 onwards is positive till it reaches 1. At 1 dy by dx is 0. And then it starts decreasing. So from 0 to 1 it is increasing, and then from 1 to infinity it is decreasing. That's exactly what I got here also. Right? 0 to 1. Did I make any mistake here? X 1 minus dy by dx is negative. When 1 minus x is negative, then x is greater than 1. That's correct. Here I think I should have written increasing. I made a mistake here. Okay. And don't forget, don't put minus infinity to 1. Okay. So with that, we'll stop with increasing decreasing function. We'll do more problems on increasing decreasing function in the next class. I hope these videos are useful to you. Okay. Kindly use GeoGebra to cross check whether your graph is good or not. If you have any questions, you can please put your doubt in the comment section. I will get back to you. Kindly subscribe to my channel and click the bell icon to get notifications of video. Have a lovely day. See you again in the next class. Bye-bye.